Okay. If you're looking at that on the toolkit for the double angle identities, do you notice which one of them has three choices? Does sine, cosine, or tangent have three choices? Cosine. Yeah, notice. So that's one thing I do want you to notice, right? The cosine of 2 theta has three choices. Okay, so this is all on our toolkit. Okay. And so how do you know which one to pick? Well, you want to pick the one with the given information. And I'll explain what the given part means in the next little segment. So I just want to point out that we're going to be talking about the double angle identities on our toolkit. The cosine of 2 theta has three choices, and the one that you pick is the one that has the given information given to you in the problem. And I'll do an example of that to show you what I mean. So the directions are always going to be the same for all of these types of problems. They're going to give you some information. You're going to figure out what quadrant you're in. You're going to draw the picture. You're going to apply what you don't know, find the formula, and plug and chug. That's really all there is to it. So the directions will always say something like find the exact value. So I'll put EV for exact value. When we find an exact value, that means we don't want to use our calculator and round off to a decimal. We want to keep our answer in a fraction form, or a square root form, or a radical form. Let's start off with something like this, something very typical. They'll say the sine of theta is equal to 3/5, and they'll say that pi over 2 is less than theta, which is less than pi. Okay, so if they give us the pi over 2 is less than theta is less than pi, what quadrant does that automatically put theta in?
3, 4.
Sounds like you're guessing.
No, 2.
2, yeah. All this stuff is in quadrant 2. So okay, so we're gonna draw a triangle that represents quadrant number 2. So here's pi over 2 right here, and then here's pi, and then my angle is somewhere in quadrant 2. It's somewhere between pi over 2 and pi. I'm not exactly sure where. So here's my reference angle. I'll call that theta. Always make sure you draw your reference angles between the terminal side and the positive x, or the positive or negative x-axis. Okay, so there's my picture. And what do I know about this particular angle theta? I know something about it. What do I know? I know that its sine is what? 3/5. So where does the 3 have to go? The 3 has to go on the opposite side. The 5 has to be the hypotenuse. So what does that make this side that I don't know? It makes it a 4, but since I'm in quadrant 2, I'm going to put a negative sign attached to it, because if I was to consider a point in this side of the coordinate plane, this would be negative 4, 3. That's why my 4 is negative. You with me on that part? Good. Now I know everything I could possibly know about that. And then the setup will be something like this. Here's part A. Now that you have this, what is the sine of 2 theta? Right? Well, the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. And I pulled that straight off the toolkit. You do not need to memorize that. I looked up there and said, oh, it's 2 sine x times cosine x, and we're just using thetas for this problem. So I replaced that with 2 sine theta cosine theta. So that means I'm going to have 2 times, what's the sine of theta? Look at the picture. Well, according to my picture, the sine of theta is opposite over hypotenuse, so that has to be 3/5. And the cosine of theta has to be the adjacent over hypotenuse, so that's negative 4/5. Then we clean it up, and we have our answer. So 2 times 3 is 6. 6 times negative 4 is negative 24. So this is negative 24/25. And that's our exact answer. What do you guys think? 5. Okay. Well, let's do part B then. Part B will ask you, okay, then what's the cosine of 2 theta? Alright, now, like I said before in the first box here, the cosine of 2 theta has 3 choices attached to it. Okay? So which one are we going to pick? Which one are we going to use to continue on with the problem? I told everybody to use the one that has the given information. So what do I mean by the given information? Well, the first one says cosine squared minus sine squared x. Why would I pick the? Why is the third one the best choice? Because it only has the thing that I'm given. Let's say, for example, that I messed up in part A. let's say, for example, that I thought the cosine was negative 7/5. Then, if I choose the first or second option for cosine of 2x, I'm going to carry that mistake into part B and get part B wrong as well. So this is a broader philosophical way of looking at it. Use the one that you can't mess up on your own. You know what I mean? So we're going to choose the third one, which says this, which is 1 minus sine squared of theta. And again, I pulled that right off the toolkit. So that's going to be 1 minus 3/5 quantity squared. Oh, did I miss a 2? Oh, thanks a lot. I didn't write that part down. It's 1 minus 2 sine squared theta. Thank you. So that's going to be 1 minus 2 times 3/5 quantity squared. So that's going to be 1 minus 2 times, I'm going to work this out, that's going to be 9/25, huh? That's going to be 1 minus 18/25. Now, what do you make your 1? 25/25, right? Fancy 1. So 25 take away 18 is 7? So this is 7/25, and we're done. Easy. So the exact value for the cosine of 2 theta would be 7/25. Okay, now let's be sneaky here. What's the tangent of 2 theta? Well, isn't the tangent just the same thing as sine over cosine? And don't we have the sine of 2 theta already figured out? And don't we have the cosine of 2 theta already figured out? So couldn't we just say negative 24/25 times 25/7 and go, negative 24/7? Oh, snap. That was slick, huh? Now, would we get the same thing if we did 2 times the tangent of x over 1 minus tan squared of x? Yes, we would, but this is way more fun. Why not do that? So, half angle identities. If you look on the toolkit there, how many choices do you have for sine?
1.
You've got 1. How about for cosine? 1. You've got 1. How about for tangent? Yeah, so the tangent of theta over 2 has your 3 choices, and you can pick any one that you want. They all work the same way. And notice that there is this plus or minus business going on in front of the sine and the cosine and the tangent. You have to pick the one where theta over 2 is, and I'll explain how you do that. The plus or minus part, the only tricky part for half angle identities is figuring out where the plus or the minus goes at the end. Everything else stays exactly the same. So we got toolkit for that. So we don't have to write them down or memorize them. We're going to use the toolkit. Okay. So here we go. Here's some information. They're going to tell you that, let's say the cosine of theta is equal to negative 3/5, and pi is less than theta is less than 3 pi over 2. All right? So if pi is less than theta less than 3 pi over 2, what quadrant does that put us in? That puts us in quadrant number 3, okay? So if I were to quickly draw a picture in quadrant number 3, here's here's pi, here's 3 pi over 2. Here's an angle in quadrant 3, here's theta, there's my right angle. I know the cosine is negative 3/5, so that means that this has to be the negative 3, this has to be a 5, and that side has to be a negative 4. I'm just using 3, 4, 5 triangles now for the basic idea. Okay, so according to the toolkit there, the cosine, I'm looking for part A. What is the sine of theta over 2? Okay, according to the toolkit, sine of theta over 2 is equal to plus or minus the square root of 1 minus the cosine of theta, all divided by 2. Which is plus or minus the square root of 1 minus, what is the cosine of theta? Do I know what it is? Yeah. It is negative 3/5. So negative 3/5 here. All divided by 2. Which is then plus or minus the square root of, that's going to be 1 plus 3/5. 1 plus 3/5 over 2. Which is plus or minus, now let's make the 1 a 5/5, right? So 5/5 plus 3/5 is 8/5. So that's 8/5 times, if I make the reciprocal of 2, 1/2. So that is plus or minus the square root of 4/5. Woo! Keep going. Plus or minus 2 rad 5 over 5. I did a little simplified the square root of 4, and then I also rationalized the denominator. Okay, plus or minus 2 rad 5 over 5. Question is, which one do you pick? The positive or the negative? And how do you know? Well, I don't know, right? Okay. Because of the quadrant, right? Well, all we know, here's what we know. We know that theta is in which quadrant? Theta is in quadrant 3, but what are we finding? We're finding theta over 2, aren't we? So here's the trick. So if pi is less than theta is less than 3 pi over 2, then pi over 2 is less than theta over 2, which is less than 3 pi over 2 over 2, which means this. Less than theta over 2, less than 3 pi over 4. So if theta lies in quadrant 1, where is theta over 2? Quadrant. Yeah, in between pi over 2 and 3 pi over 4. So in between 90 degrees and 135 degrees, what quadrant is that in? 2. Quadrant 2. And in quadrant 2, the sign is positive or negative? Positive. So this is 2 rad 5 over 5. So the only trick with half angle identities is figuring out where theta over 2 lies. You don't have to do that. Find the cosine of theta over 2. All right, cosine of theta over 2. According to our toolkit, the cosine of theta over 2 is equal to plus or minus square root of 1 plus cosine theta all over 2. And I just got that straight off the toolkit. Don't have to have that memorized. So that's plus or minus square root of 1 plus a negative 3/5, all divided by 2. Which is equal to plus or minus the square root of, how about 5 5/5 minus 3/5? 2/5. So 2/5 times a half, which is the square root of a 5th, which is 1 over rad 5, which is rad 5 over 5, right? Okay, plus or minus, plus or minus. All right, which one do we pick? Well, theta over 2 is still in quadrant 2. And in quadrant 2, cosine is what? Positive or negative? Negative. So we take the negative square root of 5 of theta over 2. Instead of picking one of those, right? Instead of picking one of those, can we just take the sine over the cosine? So couldn't we just take 2 rad 5 over 5 divided by negative rad 5 over 5? Hey. Oh, yeah. And these cancel out, don't they? So that gives me 2 rad 5 over negative 5. Hey. Negative rad 5, which gives me negative 2. Oh, man, that is way faster. So you can do that little trick at the end to find the tangent of those. So you make sure that you utilize that trick. Okay, any last thoughts or questions before we do a logarithms review for CSTs in the last 20 minutes of class? I was going fast because I want to get to the logarithm review. Yes, sir.
How did you get up the negative?
This negative right here?
No, for the cosine.
For this negative here. Because we found out that theta over 2 lies in quadrant 2. And in quadrant 2, x values are negative. And since cosine deals with x, we make a negative. All right, let me stop this.